Hi guys, in today's video we're going to look at hydrated crystals, dot formulae, how to determine our dot formulae, and finally an exam style question.
What are hydrated crystals? Well, crystals can largely take two forms. They can either be hydrated, meaning that in their structure they have water, or they can be anhydrous, meaning without water, and there's no water in their structure. And this water that's present in their structure is called the water of crystallization. This water is often incorporated when a crystal crystallizes within water, incorporating the water into its structure and making it hydrated. So let's have a look at how this is represented in formulae. Well, dot formulae are used. A dot, which we can see here, is used to indicate the ratio of water in a crystal. Now the relative number of water molecules are shown after the dot. So as an example here I've got copper sulfate crystal, which you should know and you may have seen is blue. And it's blue because of the water that's present. So hydrated copper sulfate will be blue. And for every molecule of copper sulfate there is 5 water molecules. This dot is showing there is 5 water molecules. And now this is a very rare instance of the number of water molecules or of another molecule not being in sub or superscript, but instead being in front. It's one of the only instances. And what we see from the dot formulae is the relative number of water molecules. Now it's good to note that whilst hydrated copper sulfate is blue, anhydrous copper sulfate, which we saw in the previous slide, contains no water, is white. And there are many ways which we can convert hydrated to anhydrous crystals, and one of the kind of most common themes is that we do that by heating, and we'll heat in a crucible, which is a small dish, and lay that on top of a pipe clay triangle to support it, and we'll heat with a Bunsen burner. We'll have a look more at that later in some of our later videos. So how to determine dot formulae? Well, there are 2 major ways in which we can do this. We can do this with our empirical formula, which is the simplest whole ratio of numbers, or experimental results. So the results we receive after doing experiments. Let's have a look in a bit more detail.
Hey guys, to continue watching this video and unlock hundreds of other super concise and exam board specific A-level chemistry videos, click the button. Join me today and together let's make A-level chemistry a walk in the park.